Next is Gay-Lussac's law. At constant volume, here we kept the volume constant. Volume of the gas is kept constant. Pressure of given mass of gas. Given mass of gas means number of moles also fixed or constant. Pressure is directly proportional to temperature, or mathematically we can write it as P is directly proportional to T, or P is equal to KT. When we replace this proportionality constant, we get P is equal to KT, and K is the proportionality constant which depends upon the value of volume and the number of moles. Or by rearranging, we get P by T is equal to K. It means when we increase the pressure, when we increase the temperature, the pressure of the gas also increases at constant volume. Means number of moles are fixed. If we take 5 moles, then they remain 5 moles. For example, in summer season, we have seen that in tires of the car or bikes, they burst very frequently. Why? Because with the increase in temperature, the gas molecules gains kinetic energy. It means they move faster and occupies more volume and try to come out from the tire, as a result of which they exert pressure on the walls of the tire. It means when we increase the temperature, pressure of the gas molecules also increases. That's why when a sharp needle or anything, when a tire come in contact with that sharp thing, it get burst. And this is the reason, because of the high pressure of the gas molecules due to increase in the temperature of the gas. Here we take the graph in which pressure is plotted against the temperature. When we increase the temperature, pressure of the gas also increases when the volume is kept constant. These are the graphs at different volumes of the gas, and here V1 is less than V2. According to this equation, P by T is equal to K, or P is equal to KT. Because K depends upon the volume, when K increases, volume also increases. When K decreases, volume also decreases. Here it is, V1 is greater than V2, which is greater than V3, which is greater than V4. This is V2, this is V3, and this is V4. Next law is Avogadro's law. According to this law, equal volumes of all gases under same conditions of temperature and pressure contains equal number of molecules. It means equal volumes of all gases, whether it is hydrogen, oxygen, nitrogen, carbon dioxide, carbon monoxide, for all gases. If we take 1 liter volume, if we fix this volume of all the gases 1 liter, we take 1 liter of oxygen, 1 liter of hydrogen, 1 liter of oxygen, nitrogen, carbon dioxide under the same conditions of temperature and pressure. It means they contain equal number of molecules. If 1 liter contains 1 mole, if 1 liter volume of gas contains 1 mole of gas, then all the gases contains 1 mole of gas if the volume is 1 liter for all the gases. And mathematically, V is directly proportional to N. It means when we increase the number of moles, volume of the gas also increases, or V is equal to Kn, where K is the proportionality constant which depends upon the value of temperature and pressure. But N is the number of moles which depends upon the M. M is the given mass, small m, and capital M is the molar mass. If we put this value of N in V is equal to Kn, therefore we get V is equal to, volume is equal to Km by M. Or from here we can calculate the molar mass of the gas, which is equal to Km by V, and M by V is the density. It means molar mass depends upon the density. By knowing the density, we can calculate the molar mass of the gas. This is ideal gas equation or combined gas law, in which we will combine the gas laws, and the equation which gives the simultaneous effect of pressure and temperature on the volume of the gas is called ideal gas equation or combined gas law. It means it gives the relationship between pressure, temperature, and volume of the gas. First, according to the Boyle's law, V is inversely proportional to pressure at constant temperature. This is equation number 1. It means when we increase the volume, the pressure of the gas decreases at constant temperature. And the second law, that is Charles' law, in which volume is directly proportional to temperature at constant pressure. This is equation number 2, in which when we increase the temperature, volume of the gas also increases. And in the next law, according to Avogadro's law, volume is directly proportional to the number of moles at constant temperature and pressure. This is equation number 3, in which when we increase the number of moles, then the volume of the gas also increases. By combining all three equations, we get V is directly proportional to 1 by P, T and N, or V is equal to R into 1 by P into T into N. Here R is the universal gas constant. This is a gas constant. And by rearranging, we get PV is equal to nRT, where P is the pressure of the gas, V is the volume, N is the number of moles of the gas, R is the gas constant, and T is the temperature. And this equation gives the ideal gas equation, or this is also called the combined gas law. From here, we can calculate the value of R, gas constant, or units of gas constants, like if we rearrange this equation, R is equal to PV by NT at normal temperature and pressure. Here temperature is 273 Kelvin and pressure is 1 atmosphere. Temperature is 273 Kelvin, means 0 degree Celsius, and pressure is 1 atmosphere. And if we take number of moles here, 1 mole, and volume at NTP is 22.4 liters. By substituting these values of temperature, pressure, number of moles and volume, we get the value of R here. R is equal to 0.0821 and its units are R is equal to, the units of pressure is atmosphere, the units of volume is liter, units of number of mole is mole, and units of temperature is Kelvin. It means the unit of R with this value is atmosphere, liter, mole inverse, Kelvin inverse. This is 1. This is the units of gas constant, and it is the value of this gas constant at normal temperature and pressure. Similarly, we can calculate the value of R in SI and CGS unit.